In this video, we will give you a brief overview of the EVDesigner software. The EVDesigner software is used to create vision programs for the Diamond Technologies embedded vision product line. The application has three main screens, accessible by tabs on the left-hand side. On the Create screen, you can build and test your vision program. On the Device screen, you can edit device details and device-specific settings. And on the Run screen, you can view detailed vision program results and observe the actual output from the device. When not connected to a device, only the Create screen is accessible. To connect to a device, click the Connect button on the navigation bar at the top of the screen. The connection dialog allows you to connect to an actual EV inspection device using the serial option or an emulated device for testing. In this video, we will be using an actual EV inspection device. Configuring and using the emulator is covered in a separate tutorial. Select the EV inspection device you wish to connect to from the drop-down list and press Connect. Now that we are connected, the Run and Device tabs have become available to select. First, we will take a look at the device screen. Before we continue, let's first snap an image from the device. Each of the three tabs allows you to acquire an image from the connected device by pressing the camera button at the bottom of the screen. As you can see, we have a picture of a circuit board, but it's very dark. Now if we look at the imager settings, we can see this is because the vision LED is currently disabled. The imager settings are stored on the EV inspection device itself and are not changed from program to program. This can be useful when installing multiple EV inspection devices with the same vision logic in different locations, as the lighting may need to be adjusted for each device depending on the environment. Let's set the vision LED to enabled and snap another image. As you can see, the image is much clearer now. The onboard illuminator can be used for most applications, though external lighting may be required for some more challenging environments. Back under the imager settings, the barcode illuminator level is a separate brightness value that is used when reading barcodes. This can be adjusted independently, as barcode reading and machine vision can often perform optimally under different lighting conditions. The trigger signal setting controls how a vision inspection is triggered. The EV inspection device will always respond to the software trigger over the USB or serial connection, but several other trigger methods can be configured as well. Any of the four digital inputs, the onboard proximity sensor, or the physical switch can be used to trigger a vision inspection. The device can also be set to only respond to the software trigger. Below the imager settings, we see the firmware section. This is showing us that the device currently has the latest firmware version. If a new version is available, it can be automatically downloaded and updated here. A new firmware can also be manually downloaded by pressing the Manually Update button and selecting a firmware file from your PC. Finally, the Diagnostic Logs button will allow you to download event logs from the device. These can be sent to Diamond Technologies to assist with troubleshooting if necessary. Now let's go back to the Create screen and build a simple vision program. A new part has been placed in the inspection area that has a connector populated in the top right corner of the board. We are going to create a quick vision program to detect the presence or absence of that connector by examining the contrast of that region of the image. The Features tool could also be used for this inspection. To add the tool to the program, we simply click the Contrast button. The tool has been added to the program, and we can now see the options for the Contrast tool if we select it. The tools will be executed in the order that they appear in the program list. Notice that when I added the tool, the program icon now shows a warning. You will see this icon when you are connected to a device and the current program is not in sync with the program loaded on the device. Before you run the inspection, make sure you send your changes to the device by clicking the Program button. Setting up and using the contrast tool is covered in a separate tutorial. For now, I'm just going to quickly set the gradient detection range. Now that we created the tool, we need to tell the tool which part of the image to examine. This can be done by adding regions to the program. Using regions is not always strictly necessary, but it will almost always greatly improve the processing speed, so we do recommend using regions whenever possible. To create a region, click the green plus button in the Regions section at the bottom of the screen. Enter a name for your region, and then hit Create. You can now see that the region boundaries have appeared on the image. We can resize and reposition it to cover the part of the image that we want to inspect. I'm going to place this region over the white connector on the board. The contrast tool is going to validate the presence of this component. I'm just going to create a second region quickly to show you how to deal with multiple regions in your program. Now the new region is our active region. We can drag it around like we did with the previous one. To switch between active regions, you simply select the one you want from this drop-down list here. If you want to clear the active region so that nothing is shown, click the red X. To delete a region, select it from the list and then click the trash can. Now that we have created our region, we need to assign the contrast tool to use it. Make sure the tool that you want is selected, and then click the Set Region button. Select the region you want to use from the list, and press Select. You can also change the tool name by pressing the Set Name button. Now that we have set up our simple vision program, we will send it to the connected EV inspection device by pressing the Program button on the navigation bar. We are now ready to test out the program and make sure it's running the way we expect it to. To run the program, simply hit the camera button at the bottom of the screen. So it looks like it successfully found the component on the board. Now let's take a look at the run screen. On the run screen, we can see the results from the last time the vision inspection was run. You can select each individual tool from the tool list and see some additional information in the tool output window. When a tool is selected, you can also see the region in the image and the visual results from that tool that are drawn onto the image. At the bottom of the screen, we can see a list of digital outputs and LEDs. The set state of each output after the last program is run is indicated in this list. It's important to note that this list just shows how the outputs reacted to the last program result. This is not an indication of the current state of the listed items. For example, if the green LED was set to flash if the inspection passed, the green LED would be listed as on until the next program result was received, even if it only came on briefly. Next to the digital output, we see the serial output. This is the inspection results string that was generated and sent to the host system as a result of this inspection. Finally, if you take a look below the image, you will see that the screen has two camera buttons. The one on the left snaps a single image, and the one on the right starts a periodic trigger. While on the run page, this will automatically trigger the inspection every few seconds, which can be useful for testing. Let's swap out the board for the original one, without the connector, to see how the results are reported. And we're going to snap another image. Without the connector populated, the average gradient in our region is well below the passing threshold, and our Component 1 tool has flagged this inspection as a failure. This has been a brief overview of the EVDesigner software. More in-depth examples of how to set up the contrast tool, as well as tutorials on additional software features and vision tools, can be found in our other videos.